The last of Newton's three laws is the third law, and this looks at how forces interact. If you have multiple objects interacting with each other, what can we say about that situation? So Newton's third law is that for every action force, there is an equal and opposite reaction force. So for every action force, there's an equal and opposite reaction force. And we write this out mathematically as F of A on B is equal to negative F of B on A. So in other words, if object A pushes on object B pushes back on object A in the opposite direction, but otherwise they have the same magnitude, right? Because you'll have something like 2 equals negative 2, right? And so that's where we see that their magnitudes are the same here. So these are called action-reaction pairs. And you can tell if something's an action-reaction pair if it obeys the following rules. So if describing all your forces, you have exactly 2 objects are involved. So this is object A and object B. It does not work if there's 3 objects involved. It only works if you have 2 objects involved. Forces will always act on the different objects because it's the force of A on B and the force of B on A. So if you have 2 forces acting on a single object, even if they're equal and opposite, they will not be action-reaction pair. So a push and pull on a single object, not an action-reaction pair because it's all acting on a single object. Forces are always equal and opposite. This is just from our definition from before. And they always have to be the same type of force. So if you've got a push or a pull, that's what we're talking about here. So i.e. push / pull. That's what we have with an action-reaction pair. So let's look at some examples here. So first of all, Mr. McKinnell pushes down on desk. That's the action, that's one of the forces. Desk pushes up on Mr. McKinnell. So you'll notice 2 objects, Mr. McKinnell and the desk. Desk and Mr. McKinnell, exactly 2 objects. They're acting in opposite directions, down versus up. They're acting on different objects. One acts on the desk, the other acts on Mr. McKinnell. And they're both pushes. So Mr. McKinnell pushes down on desk, desk pushes up on Mr. McKinnell. Another example, Mr. McKinnell pushes, let's do a pull example, pulls left on the chair. Chair pulls right on Mr. McKinnell. So if I pull a chair to the left, the chair pulls back on me with the same amount to the right. So again, 2 objects, Mr. McKinnell and the chair. They're both pulls and they act in opposite directions. If we talk about how strong these forces are, we'd have the same number there. And then lastly, let's write it the other way. The earth pulls down on Mr. McKinnell. And I'd like you to pause here and maybe guess what do you think the reaction force is. Maybe write that down. Okay. The reaction force to the earth pulling down on Mr. McKinnell is Mr. McKinnell pulls up on the earth. So again, 2 objects, earth and Mr. McKinnell. both the same type of object and opposite directions. So this is true. If the Earth is pulling down on you, which it is, you are also pulling up on the Earth with the same strength of gravitational pull. We'll talk more about that in class and kind of as you explore things, but this is the basic gist of Newton's third law.